Hey everybody, and welcome to a satisfying wild ride with Steve-O. You know, some of these episodes we just are really interested in, and this is one of those episodes. And man, was it just satisfying to be able to talk to the man at the forefront of quantum computing, the leading quantum physicist of our time, and be able to ask him all kinds of practical and frankly impractical questions. I think the balance of informative and entertaining and just downright fascinating on this episode, it's all of those things, and really really wonderful, man. I will add to that this little precision mission to New York, the range between the guests we spoke to there. I mean, talk about a versatile podcast. Watch out, Rogan, because we can do it all. So let's get into it. Ladies and gentlemen, people of the universe, I bring to you Dr. Michio Kaku.
How do you do? Glad to be here on the planet Earth with you guys.
Well, thank you. It's a big honor.
Mm-hmm.
Very safe to say that in the world of scientists, that you're on the Mount Rushmore.
Well, I try to convey the excitement and the drama of science as we begin to probe the ultimate nature of reality itself.
Yeah, and I'm profoundly interested by the nature of reality because I think that we've got it all wrong.
Well, how would you recreate reality if you were God?
Well, let me qualify my statement. I think we've got reality all wrong. I think that scientists cling to the notion that consciousness is generated by the brain.
Mm-hmm. It's a byproduct of the neural processes, right?
And so you're on that team? You believe?
Yeah, that's right.
Okay.
Consciousness emerges from the neural networks. We can talk about a cosmic consciousness, but that's a whole nother ball of wax.
Ooh, I think I'm very interested in the cosmic consciousness because my view on it is that I would make an analogy, a metaphor that we should stop viewing the brain as a transmitter and more as a receiver. Like, for example, if we think about a radio, the radio doesn't create the signal, it receives the signal. So if you were to hypothetically take a baseball bat and smash the radio into oblivion, you've done nothing to harm the signal. And so I think that consciousness is more the signal, and the destruction of the human body does nothing to harm it. So that's where the idea of life is eternal kind of kicks in for me. And I wonder if you could react to that.
Well, I have a different point of view on consciousness. I think that even inanimate objects, animals and objects can be conscious. I think the smallest unit of consciousness is a thermostat. A thermostat understands the surrounding temperature and makes an adjustment. So a feedback loop that allows you to accommodate the environment is, I think, the unit of consciousness. A plant, I think, would have maybe 10 units of consciousness. It analyzes sunlight, water, temperature. That's the consciousness of a plant. Then we go to maybe an alligator. An alligator may have, I think, several hundred units of consciousness because they have to find the prey. They have to have a three-dimensional representation of reality. And the back of the brain is that reptilian brain. And as we evolved from the reptilian brain, the brain went forward to become the monkey brain. And the monkey brain is the brain of social networks. That is hierarchies. Who's your friend? Who's your enemy? Who's your ally? That, I think, is the monkey brain, which is the center of the brain. Then the big question is, what are we on this chart? All the way starting from a thermostat, going up to a plant, going up to an alligator, going up to a monkey. Where are we on this consciousness scale? I think our consciousness is the prefrontal cortex.
Ah.
What am I going to do tomorrow? What the hell am I doing here, right? You're thinking about the future, okay? So the prefrontal cortex, the front part of the brain, is the human brain, the brain that sees the future. Now let's do an experiment to prove my theory. Go home tonight and talk to your dog and teach your dog the meaning of tomorrow.
Right.
You can't do it. You cannot teach animals the meaning of tomorrow, okay? We, on the other hand, live in tomorrow. We're constantly thinking about what am I going to do today? What am I going to do tomorrow? What the hell am I doing here today? This is what we consciously think about. And so that's why I think that that's the human consciousness which separates us from animal consciousness, which talks about space and time, space. But our brain talks about time. It's a time machine.
Right.
Is there such a thing as AI consciousness?
I think we're getting to that point where robots can eventually begin to see maybe a little bit into the future. But right now, robots live in the present. They're very primitive, and they only live in the present. We, on the other hand, live in the future. That is what distinguishes the prefrontal cortex, the front part of your brain, from every other animal's brain.
Yeah, the ability to contemplate a reality, a moment outside of the present moment.
That's right.
That is unique to humans. There's
That's
no
right.
other living organism that can do that.
That's right. No other organism thinks and lives in the future. We constantly live in the future.
Yeah.
We're constantly thinking about things that are even going to happen after we die. Okay?
Right.
Even after we're not here, we constantly think about what the universe is going to be like after we're gone. Animals don't do that.
Right.
Animals live in the present.
So by that measure, it's safe to say that humans are the only living organism with the capacity to fear death.
I think so. We're the only ones. Because for animals, they don't have to do that, okay? We, on the other hand, we're not blessed with claws and armor and wings. We don't have all the advantages that animals have. The only advantage that we have in terms of evolution is the brain. And the brain imagines the future. That's why we survive. That is the Darwinian reason why we are like that. Because we're not strong, we don't have talents, we don't fly, we don't have claws, we don't have fangs, none of that. The only thing we have going for us is the brain, which sees the future. That is what distinguishes us from all animals.
Yeah. And the concept of money kind of fits into that, right? But like, because it's less about whether it's the future, but we can tell a story about something which you can't see or touch in the immediate space, something that's not tangible. And I think that's another thing that animals are not capable of doing. So animals would never be able to have money.
Yeah, and what is money? I think I'm a physicist, and we break everything down in terms of two things, energy and information. That is the basis of all life, even intelligent life in the universe. And money is a representation of energy. It allows you to do things. It's a representation of energy. So energy and information are the two ways in which we rank civilizations. We can rank animals. We can rank everything in terms of energy and information.
I wonder if...
but are like monkeys like hoarding bananas as a form of currency to start bartering, or they're just kind of day by day?
Well, the bananas and energy is a form of energy. And that's why animals understand that food is energy, and you can bargain with that. And so, like I said, everything can be reduced in terms of energy and information.
I feel compelled to push back on the idea that money is energy when it's so fictional. It's just an idea. It's not. It's
an idea that can do things. Energy is the ability to move objects. That's what energy is. And that doesn't mean you're moving objects now. It means you can move objects.
Right.
And that's what money is. Money is a form of energy, stored energy, because it allows you to do things in the future.
Right. So by that measure, then energy and power are interchangeable terms.
Yeah, power is a form of energy. That's right. And so when we physicists look at alien life in outer space, that's how we rank civilizations in outer space. So, for example, Kardashev ranks civilizations of the future. A type 1 civilization harnesses the energy of a planet. So it's planetary. They control the weather. They control earthquakes. Anything planetary they control. That's the energy of a type 1 civilization. Type 2 civilization controls the energy of a star, like Star Trek. Star Trek would be a type 2 civilization because they can play with the few stars in this sector of the galaxy. Then there's type 3. Type 3 is galactic. They roam the galactic space lanes like Star Wars. Star Wars would be a type 3 civilization. Now, what are we on the scale? Are we type 1 that can play with the weather? Are we type 2 that can play with the sun? Are we type 3 that can play with the Milky Way galaxy? No, we're type
0.3.
0.
But aren't we starting to manipulate the weather like in Dubai? They can shoot salt pellets into the sky and make it rain. In the Olympics in China, they're worried about the pollution, so they shot the salt pellets and made it rain to move the pollution out of them. I mean, isn't that a form of...
Yeah, well, Carl Sagan was asked that question, and he estimated that we're actually 0.7.
0.7.
Okay, because by the end of the century, we will be type 1. Right now, we're type 0. Okay, we get our energy from dead plants, oil and coal.
Yeah.
That's type 0. We're at the bottom. Okay, we don't even rank on this scale. But we're about 0.7 when you actually do the math in terms of energy consumption. By the end of the century, we'll be type 1.0. So our grandchildren will live in a new civilization, a planetary civilization, a civilization that can more or less alter or control the weather, volcanoes, earthquakes, anything planetary they can begin to influence. We can only dream about that. But that's a type 1 civilization. In other words, the civilization of Buck Rogers and Flash Gordon, that would be a type 1 civilization.
Mm-hmm. I'm very interested by the notion that we will be controlling the weather by the end of the century. It's just really hard to imagine a world where things aren't out of our control. I mean, that's the reality we live in. You never know what's going to happen, and you want to make sure that your family is set up if something terrible does happen. And that's why life insurance is an important thing to check off your list. And the country's leading online insurance marketplace is Policygenius, and they've got you covered, man. If you go to policygenius.com, then you can get in one day approval for life insurance policies that cost as little as $290 for $1 million worth of coverage. I mean, get out of here. That's incredible. You can have that kind of a safety net to protect your family with $1 million, and it's going to cost you is $290 some per year. That's incredible. Thank you, policygenius.com/Stevo, for hooking up the listeners of the Wild Ride so well. So, one more time, you can't control certain things, but you can control your family's future. So go to policygenius.com/Stevo for an incredible deal on life insurance, and let's get back to it. Can you help me understand what that looks like?
Well, in terms of the weather, we realize that we're just a blip on the screen in terms of energy consumption. That's why Carl Sagan said we're 0.7. But once we get 1.0, we can begin to influence tornadoes, begin to influence humidity, and begin the process of altering the weather, which we can only dream of today. Okay.
And what would it look like what's the technology in adapting the ability to influence the weather?
Well, again, it's energy. Okay. We're going to have much more energy available to us by the end of the century. We're going to have fusion power, for example,
now
within 10, 20 years. And with that energy from fusion, we'll be able to begin the process of altering the weather.
Is fusion like nuclear, or is it different, or is it similar?
Well, uranium is what most people think of when they think of nuclear. But I'm not talking uranium.
That's what Doc Brown was trying to get in Back to the Future. Was
right,
that uranium?
With the portable Mr. Fusion.
Yeah.
Right. Yeah, fusion power is the power of hydrogen. It's the power of the sun. Nowhere in the galaxy we know of does a civilization use uranium except us. We're the only ones who use this backward technology called uranium. The universe uses hydrogen. That's what the sun burns. The sun burns hydrogen. It's clean, no nuclear waste, does not melt down, and is basically almost for free. The only waste product of a fusion plant is helium gas, which is commercially valuable. You can actually sell helium gas.
Why haven't we been able to get that? Is it just because we haven't figured out the math? Is it like math, or is it something different? Like we have to go in steps and phases to the technology?
You have to heat hydrogen gas to tens of millions of degrees. The sun does it by gravity, because gravity compresses evenly like a ball being compressed, okay?
Yeah.
However, on the Earth, we can't do that. We don't have magnetism. We don't have hydrogen that can be compressed like a ball. We have a donut instead. We create a magnetic field in the shape of a donut, squeeze the hydrogen gas in the donut, and then create fusion, okay? Now that, of course, is very awkward, but Mother Nature does it spherically. That's why we have stars. Stars are spherical. That's why they're so easy. They form by themselves. By themselves, stars form because they're spherical, because gravity is unipolar, okay? Magnetism is bipolar. And that, in one sentence, is the reason why we don't have fusion plants everywhere. Bipolar compression is much more difficult than unipolar compression. Nature compresses stars evenly by gravity. That's unipolar. We have to create donuts on the planet Earth and squeeze the hydrogen gas as a donut, or use laser beams. And that's what was done in Livermore National Laboratories in California just last year. Laser beams heated hydrogen pellets to tens of millions of degrees, and we attained break even. So we're now at the beginning of a fusion era.
And that has to do with lasers.
Lasers that are being used in California. In France, they use magnetism.
I just read that some country they just created a submarine that travels like an infinite amount of speed using lasers. Have you heard about this?
No, but
Isaac, can you look that up? Just like maybe type in like a submarine that propels itself with lasers. Yeah, Chinese use power lasers to go ultra fast. If you can see on the screen right there, I don't know if you've seen that before. But the reason I'm saying that is because, like, you know, Neil deGrasse Tyson was talking about, you know, how do we travel faster than the speed of light? And then he started talking about lasers. Does lasers help things propel faster than what we can?
No.
No.
To break the light barrier, to go faster than the speed of light, you have to use a whole new set of physical equations. You have to create, warp drive, basically. Einstein, in 1935, came up with the wormhole. And a wormhole is a shortcut through space and time, requiring the energy of a star. But think of Alice in Wonderland. The looking glass of Alice is the wormhole. It's the gateway between two universes. And the person who wrote Alice in Wonderland was Charles Dodgson, a mathematician from Oxford who couldn't use his real name, so he invented a name, Lewis Carroll, to write Alice in Wonderland. But Alice in Wonderland is based on a wormhole. That is a gateway between two parts of the universe. And if you can then negotiate through a wormhole, then you can go faster than the speed of light.
Is that what the gargantuan was in Interstellar? If you've seen that movie, it's a black hole, right?
Interstellar was they consulted with physicists, and at the end of the movie, they begin to reveal the secret of going into outer space, and it was basically warp drive, and they basically used string theory to justify it. At the last scene of the movie, Matthew McConaughey is floating.
Yeah,
he's floating
around Jupiter.
What is he floating in? He's floating in hyperspace, a higher dimension, which is the home of string theory, which is what I do for a living.
And does that have to do with like the tesseract? Like what?
A tesseract is a higher dimensional unraveled hypercube. So that gives you a glimpse of what the fifth dimension would look like
in 3D.
Right. I'm a string theorist. I work in 11 dimensions. And in 11 dimensions, we think that we can, quote, read the mind of God. We think that the 11 dimensions is the ultimate dimension of space-time.
Yeah, so that's because when you were working on string theory only made sense if there was 11 dimensions.
That's right.
I don't even know what that means, to be honest with you, but I like
it.
I think I saw one of your videos a while ago, but like can you explain what that means to me? Because there's 3D, there's 4D, there's 5D. Why would string theory make sense in 11D?
Well, we have four forces that rule the universe. We have gravity, we have light, and we have the two nuclear forces. And in 4 dimensions, the world that we live in is not big enough to harness all 4 of these forces. You have to go to a bigger room in order to accommodate the forces that we see in nature. And that's the 11th dimension. In 11th dimension, there's enough room in which to accommodate all the forces that we see in nature. So strings, each vibration of the strings would be a particle. So an electron would be vibrating like this, and a proton would be vibrating like that. That's why we have so many particles, because we have so many notes on a vibrating string. So physics is the harmonies that you can create on all these vibrating strings. Each vibration is a particle. And then chemistry is basically the melodies that you can play on these vibrating strings. The universe is a symphony of vibrating strings. And then the mind of God that Albert Einstein wrote about eloquently would be cosmic music resonating through 11-dimensional hyperspace.
But he didn't know about string theory.
What?
Einstein didn't know about string theory yet, right?
No, but he was on the verge, I think, of getting something very close to it. I've gone through Einstein's old notebooks.
The theory of everything.
Yeah, he was looking for the theory of everything. And he was trying to create different universes which would accommodate the Big Bang and accommodate the universe of today. And he failed. The mathematics of 1930 was not powerful enough to do it. The mathematics of today is powerful enough. And he was basically leaning towards string theory, but no, he never got there.
Wow, that's fascinating.
It is.
I was asking the guys yesterday. I'm an idiot, but I really like space. You know, like it's just so fascinating. And I was talking to the guy. What are you laughing at? But I was like, maybe you can like help me understand like the size of the universe. And what I mean by that is we have a sun. I'm gonna try to get this out from my brain to my mouth in front of all these cameras right now. But we have a sun, and within our Milky Way galaxy, there's about 300 to 500 billion suns,
stars,
right? And each one of those suns has planets going around
on
them.
average, right?
Okay, so that's how big the Milky Way galaxy is.
Yeah, it's pretty big.
Outside of that, we have like the Andromeda galaxy would be our closest, right?
About 2 million light years from Earth.
2 million light years away. But so then getting out of that, we have about 300 to 500 billion galaxies, right? That all contain.
That's in the visible universe. Then we have the invisible universe beyond that.
That's not black matter? Is that
no. Just what we can see. We can see out to maybe a few 100 billion galaxies. That's the limit of our telescopes. But beyond that, there are more galaxies, even beyond the range of our telescopes.
Go ahead.
Well, when Scott said this yesterday, I said that I wanted to push back a little bit and suggest that maybe it's not a case of how big the universe is, but maybe it's actually equally small. Hold that thought while I tell you about something that is not small. In fact, it is the biggest, most generous offer that the Wild Ride listeners have ever received. And it's for the cat lovers. I'm talking to you people who own cats. It is time to start treating your cat like you actually love them by switching their food to Smalls. Why would you do that? Because it is preservative-free, fresh, protein-packed food, which lives in your fridge because it is that fresh, and that's why veterinarians.org rates Smalls cat food 10 out of 10 for ingredient quality. Now here's how big the deal is. First time order, you get 50% off plus free shipping if you go to smalls.com/Stevo and use the promo code Stevo. Now, not only are they so sure that you're going to love it, your cat's going to love it, that they're giving you 50% off your first order plus free shipping, but it's risk-free. Heaven forbid, if your cat didn't eat it and love it, they'll refund your money. I mean, that's how sure these people are in what they have, and I'm telling you, my cats love it, and I couldn't be a bigger fan. So this is a match made in heaven. My cat people, do this. Go to smalls.com/Stevo and use the promo code Stevo for 50% off your first order plus free shipping. Do it for your cats. Do it for the Wild Ride podcast. Do it to just feel good about yourself. Now let's get back to it. I mean, to qualify that statement, I've heard it said that as much as you can say, oh, but what's beyond that? What's beyond that? What's beyond that? And it goes on and on and on forever. You can also cut something in half and then take that and cut that in half and take that and cut that in half equally forever. You can go down small forever and you can go big forever. So that to me begs the question, is it really a case that there is space and matter? And is it not more in kind of a quantum sense, like where in a little bit of a video game, where you only, like the video game will render just the portion that you're looking at, right? Like, and in a video game, there actually is no space. It's just, right? It's nothing, essentially.
Simulation.
Nothing and everything.
Well, this is what string theory says. String theory, first of all, says there's the ultimate smallness. The smallest distance you can go is called the Planck length, which is the size of a string, which is billions and billions of times smaller than an ordinary atom. So that there is a limit to how small you can go.
Ooh.
Then how big can you go? We're talking about the fact that our universe, in some sense, is like a bubble. But there are other bubbles out there. And these bubbles can fission to create other bubbles. And so we think that this is a bubble bath. And so that's what the Big Bang is. The Big Bang is when these bubbles collide or they pop into existence. So that's the Big Bang. So in other words, we're talking about continual creation of universes. Universes are being created even as we speak. Even as we speak, universes are popping into existence, okay? And so this is a theory, but we think that this is eternal creation, that universes are like balloons or bubbles. Bubbles are being created all the time like boiling water.
Okay.
And so that's why they say, like, there are realms of possibilities where we've been here before a million times. I've been you in one type of reality, and it's been all different ways. Is that?
Well, that's the multiverse, right? And there are Hollywood movies. It's the hottest thing in Hollywood now is the multiverse. Spider-Man can exist simultaneously in different universes. The multiverse idea comes out of physics.
Yeah, quantum physics.
Quantum physics, in fact, okay? In fact, back in the 1950s, people began to toy with the idea that the theory of the atom exists in many parallel states. And that's the reason why quantum mechanics is so wonderful, that particles can exist in multiple states at the same time, therefore enlarging the universe of what's possible. And that's called quantum mechanics, which is the basis of physical reality. So the idea of the multiverse, which dominates Hollywood movies now, comes from physics.
And is that the same theory? And I think that Einstein touched on this, that every possible outcome, every possible situation all exists simultaneously in just one moment of now.
Yes, this is called the Schrodinger cat paradox. In philosophy class, you learned about different paradoxes. But the ultimate paradox, the mother of all paradox, is the cat problem. That if I put a cat in a box, okay, and I put a gun next to the cat, okay, there's a certain probability that the gun will fire and kill the cat. Or perhaps the gun doesn't fire and kill the cat. In quantum mechanics, you have to open the box. You have to make an observation. But before you open the box, and this is the killer, before you open the box, the cat exists in all possible states. Dead, alive, semi-conscious, sleeping, whatever. And then when you open the box, all of a sudden you see that the cat is alive and healthy. Now, Einstein hated this idea. He hated this cat problem, and he said that's the reason why quantum mechanics is wrong. Well, Einstein was wrong.
Okay.
We do this all the time. We do this with electrons. That's why we have laser beams. That's why we have electronics. That's why people are listening to this program. You're listening to this program precisely because of the Schrödinger cat analogy that I just mentioned, that electrons can exist in parallel states at the same time. That's called the multiverse, which is, of course, profiled in the movie that hit the Oscars last year. Everywhere,
Sorry. Anywhere and Everywhere All at Once?
That's right.
Yeah.
Yeah, that's based on the idea that electrons can be anywhere at the same time. Why not people?
Okay. What's the test they did where the slits, where if the
Yeah. But they shoot it through.
if the particles are observed,
Right.
they do one thing, but if they're not observed, they do the other thing.
Right. You take a sheet of paper and put a hole there, right? And you shoot two holes there. You shoot electrons through it. What's on the other side of the paper? There should be just two holes, because you have two holes in a sheet of paper. You shoot electrons through it. Two holes allow electrons to pass. You should see two holes on the screen. Nope, that's not what you see. This freaks people out. You see multiple states, as if the electron exists in multiple states at the same time.
And whether or not it's observed seems to be the distinction between how it exists.
Well, your mother used to say you can't be two places at the same time. Your mother used to say that, right? She was wrong. At the atomic level, electrons are many places at the same time, and that's called electronics. That's why we have electronics. If it wasn't for that, there'd be no telephone conversation. No radio conversation today. All reality as we know it would collapse. It all depends on the fact that we exist in a multiverse.
Wow.
So when I look in a mirror, I say to myself, is that really me in the mirror? I begin to realize that I exist in many parallel states. And I'm just looking at one of the parallel states that I'm looking in a mirror. And it kind of freaks you out when you think about it. But hey, it's called physics.
That's great. I saw that a scientist sought to determine at which point has the human population grown so much that it's not sustainable, that the Earth can't sustain it. And the answer that this scientist found was that happened in 1970. That we were consuming natural resources on Earth to a point that it was unsustainable. And so that made me start to think, oh, well, there's too many people, there's too much consumption, that the world as we know it can't continue, and that civilization as we know it, its days are numbered. But then on the other side, I've also seen arguments that depopulation, the population becoming smaller because people are procreating less, is an even bigger problem. So I want to ask you, what do you think is the bigger problem? Too much population, too many people, or too few people, depopulation?
Well, Malthus, the great visionary in the last century, said that as we populate ourselves, we grow maybe exponentially fast in terms of population, and we basically eat ourselves out of existence. Okay, so we're doomed because of this fact. That never happened because of, quote, the Green Revolution. And the Green Revolution took place before World War I, when we discovered how to make fertilizer. Okay, nitrogen in the air, okay, can be fixed with fertilizer on the ground, so that plants can now benefit as well from the fact that we can create unlimited quantities of fertilizer. But now we're running out of that we need a second green revolution because the population keeps on growing. And so that's why we need things like quantum computers. We need a whole new set of chemical reactions so that we create a second green revolution so we can fix nitrogen from the air to create fertilizer. Now, the good news is the population is actually shrinking in several areas of the world.
Yeah.
In Japan, for example, there are ghost towns emerging because the population is shrinking. People are moving from the countryside into Tokyo. So in Tokyo, it looks normal, but outside they're ghost towns because children's parents die, they move away, they don't want to rebuild the house, and they simply let the house go. And so ghost towns are forming. So the same thing is happening in South Korea now. It's happening in many areas, and it's beginning to happen in Europe now. So the population, people are not having 10 kids anymore.
Right.
Now, why do we have 10 kids? Because of the fact that there's no Social Security in a lot of primitive countries. That's why people have 10 kids. That's your Social Security.
Yep.
You literally give birth to your Social Security.
I hate to break it to you, amigos, but I really don't think having kids is the way to secure your future anymore. In fact, if you want to secure your future, it's time to start making things happen. And by making things happen, I mean making money. And that way is ShipStation. Man, the thousands, over 100,000 orders that I've personally shipped out of my warehouse to my customers using ShipStation. It's incredible. Couldn't be easier, and it all fits into one easy-to-use interface regardless of what platform you're selling with. If you've got Amazon, Etsy, your own website, eBay, it all works in one interface. Plus, it brings into that same interface all of the major carriers, United States Post Office, UPS, FedEx, and it gives you the best rates for those carriers. Rates that are normally reserved for Fortune 500 companies, you get. And what's even better, you can try this out for free. If you go to shipstation.com, shipstation.com, and use the promo code STEVO, then you are eligible for a 60-day, that's 2 months, risk-free, totally for free trial period to just figure out how easy it is, how affordable the shipping is. I mean, come on, let's get that future secure by going to shipstation.com and using the promo code STEVO to make ship happen. It's time to become your own boss, make your own money, and make your future bright. So shipstation.com, use the promo code STEVO, and let's get back to it.
Now, of course, we put children in schools. They don't work in the fields anymore, okay? They're a negative in terms of consumption, not a positive. They're a negative now.
It's such a good way to put it.
So instead of having 10 kids, how many kids you want? 1.5. Okay?
Right.
And that's what's happening to the world population now, except sub-Saharan Africa. Sub-Saharan Africa, the population is still growing. The curve, of course, is not quite as steep as it used to be, but it's still growing. But everywhere else, in Asia, in North America, Latin America, populations are stabilizing and going backwards. Now, we don't see that in the United States because of immigration. In Europe, you see it. And in Asia, you really see it. China, Japan, Korea, populations are shrinking in those countries.
Big time.
And the governments are trying to encourage people to have kids. It's not working.
Right.
For some reason, people are not having that many kids.
Well, right. And China had that one baby law.
Right.
Where you were only allowed to have one child because they were worried about the population becoming too big, and now it would seem China.
They went the other way.
Yeah, now they're perhaps regretting their one baby law, and they really want to have people to have children.
Right.
And having children used to be an insurance policy because not even necessarily so much that your kids would be working in the field as opposed to going to school, but when you became old and needed to be taken care of, you would have all these kids there to take care of you. But what's happened is the opposite, where children have become really expensive pets that when the child becomes an adult, it's actually the parents still taking care of the child, and the child never takes care of the parents.
So all the predictions were wrong. We're going the opposite direction of having fewer kids, and other countries now are trying to encourage families to be created, because otherwise the populations are just going to drop, which means labor costs are going to go up. It's going to cost more to have someone take out your garbage because of the fact there are fewer people. And so nations have to worry about this. This is a number one thing on the agenda, how to deal with the implosion. Remember the population bomb that was supposed to hit in the year 2000?
Yeah.
It went the other way.
Right.
All those predictions went wrong.
I think a lot of people probably won't necessarily understand why it's a problem, because I certainly didn't without it being explained. But we've got the what's called the baby boomers, is the one generation that was the largest in the population really grew when everybody came home from World War II. The baby boomers, there's so many of them, and now the baby boomers are not working anymore. They're retired. So they're getting the Social Security, they're all these benefits, and they're not generating income to tax and to.
Don't say that too loud. Some politician may hear it.
Yeah.
Be quiet.
So now you've got the more of the population effectively being a drain on the economy without working and generating income, while the actual working population is the smallest. So there's just not money to feed everybody, and there's not money for taxes, and there's not enough people, like the doctor said, to take out your trash. So I think implosion really is the word.
But do you think, like with Tesla and Apple, they're coming out with like the iHome robots where it has like, do you think that's going to affect how many kids people have? Because like, you don't need anybody to take out the trash anymore or whatever.
That was the unstated solution to the problem in Japan. Japan says, yeah, the population is collapsing in Japan, but we're advanced in robots. Robots will save the day. Well, surprise, surprise. Robots today are pretty stupid. And they're still stupid, and they're going to be stupid for a few more decades. We realize that intelligence is very difficult to create in a mechanical robot. And so the robots in Japan, you can barely talk to them. They're not the workers of the future. So, people are working on robots, but we got a long ways to go.
But when quantum computing comes into play, will that help at all?
That could help. You see, artificial intelligence that we read about in the newspapers, right, is not artificial intelligence of you're talking to like a human. You're talking to basically the internet. These software programs allow you to get huge chunks of the internet.
Like ChatGPT.
Yeah, right. And modify it like an editor, splice it together, and give it to you, and it sounds like a human wrote it. That's because a human did write it. Yeah. All the computer did was edit it. Okay? And so these are not thinking machines. Some people are afraid because you talk to the machine talks back to you like it's a human. It does sound like a human because it was uttered by a human. All the computer did was edit it. So it sounds human, but it's not. So these things don't think. So they're not going to take over. Some people are thinking that the robots are so advanced they're going to take over. No. These robots are basically editors. They edit what's available. They don't create anything new. They don't know the difference between right or wrong, true or false. That's why they'll print all sorts of nonsense. Okay.
When you say that AI is editing, what you mean by editing is that it's just sequencing words based on the probability or the most common sequencing of words that it's gleaned from all of the data that it's consumed.
Right. It has an algorithm by which it chooses the next set of words given the present set of words, but it doesn't think. It's not thinking like a human. It sounds like that because when you listen to it, it sounds like a human talking to you because in some sense it is a human talking to you. It's just been edited and spliced by a software program.
It's so impressive. We spoke with
Dr. Phil?
Well, no, Duncan Trussell.
Oh.
And he was telling us about this AI software that creates music just immediately. And I said, oh, wow. And he said, yeah, any kind of genre of music that you want, and tell it what you want a song to be about. And I said, I want a heavy metal music song about having to pee too frequently. And boom, it came out, and the song was really impressive. Then we asked for a hip-hop song, a rap song about having to pee too frequently. Country music, and it just came out immediately.
Can we make a rap song about string theory right now? I wonder if how accurate that would be.
I don't know how big the audience would be for that.
No, but he's typing it in right now, and he's going to create it, and it's going to... I guess you have to sign in.
Let's let that live in the Duncan Trussell episode. We can do better. We can do better. But now, I just want to come back to the question I asked before. The bigger problem: too many people or too few people? Which do you think?
I think it's uneven. I think in sub-Saharan Africa it's going to be too many people, but in Europe and the United States it's going to be too few people. And so I think that there's going to be two populations, one population growing and the other population shrinking.
So it's going to be the worst of both worlds.
In some sense, yeah. And no one's talking about it because it's too sensitive. People don't want to think about the problem. So we're just blindly going off the cliff.
Right. Now, a lot of people will speculate that technology is always going to catch up and come up with the solution to save the day. And I don't necessarily disagree with that notion, but what is the solution? And I saw AI is somehow generating new proteins that have never existed in order to create new like vaccines, new food. Is that something that we can expect the next green revolution to be? Is AI creating new proteins which are somehow able to feed the too many people?
Or like new mathematics coming from AI.
Well, I mean, that's the goal. One of the goals of artificial intelligence is to create new proteins, new amino acids, new combinations, but it's still hit or miss, okay? That's where quantum computers can come in. How do we get new drugs for today? Believe it or not, new drugs are created by trial and error. You get thousands of Petri dishes, put the chemicals in these Petri dishes, and cross your fingers that the chemical that you put in will kill the germ. That's how penicillin was discovered. Penicillin was not discovered deliberately. It was discovered by accident when they realized that bread mold was dying because the germs were dying, okay? So we're still in that era of trial and error to find new drugs. With quantum computers now,
you can try millions of things in 1 second.
In principle, we'll look at the molecular level and begin to tinker with the molecule itself, rather than simply, crossing our fingers, hoping and praying, closing our eyes, and hoping that one of these Petri dishes out of 1,000 will work against that germ. We'll be able to look at the weak spots of the germ at the molecular level, and we'll be able to begin to intervene with this process. So things that we used to think were incurable, like cancer, Alzheimer's, Parkinson's disease, we're beginning to understand the molecular basis for these things. For example, cancer, there's one gene called P53, which is a very long gene, but it's involved with 50% of all common cancers. One gene. If we figure out the way to cure the breaks in this one gene called P53, we may find a way to cure many cancers. And this is where quantum computers come in, because that's the home of quantum computers, molecules. So we'll be able to create new molecules that will actually, hopefully, begin the process of curing incurable diseases, maybe even the aging process. We're beginning to understand how aging works. Why do we get old? We get old because of the buildup of errors. But where do these errors come from? If I have a car, where does aging take place in a car? The engine.
Okay.
That's why cars get old. It's the engine, because you build up waste products, sludge, and stuff like that in the engine. But the cell has an engine too, the cell of our body. It's the mitochondria. That's where aging takes place. And so if we find a way to correct the mistakes, like in P53, we might be able to slow down the aging process and maybe even attack cancer. Now, that's, of course, the hope. We're not there yet. But the hope is at the molecular level, we'll be able to crack these diseases.
I'm fascinated by this. When you said aging is, it's the function
Build-up of
a
error.
collection of errors.
At the cell, right? Cellular molecular error. That's what aging is.
Can you help me understand what you mean by an error in a cell?
Well, cells contain molecules. Molecules have to have a very specific function. If one of these molecules is broken or misshapen or is out of control, then it no longer performs like it used to. Okay, and then eventually the protein becomes inert, and eventually it dies, and that's why you die. For example. Skin cells divide 60 times, and eventually they stop dividing. Too many errors build up, and they die. That's why skin cells die. But also there's a way to stop the clock. The telomeres is this cell that gets shorter and shorter and shorter until the cell dies. That's why you die, okay? 60 reproductions in the skin cell, and it's all over. But there's something called telomerase, which stops the clock. Okay, a Nobel Prize was given to the people who discovered telomerase. It actually stops aging. You can get skin cells to divide thousands of times now, not just 60. Now, what's the catch? There's always a catch someplace, right? Otherwise, we'd all have the fountain of youth.
Yeah.
The catch is, this is how cancer immortalizes itself. Why does cancer kill you? Cancer kills you because cancer cells are immortal. They don't die. They keep on dividing until you die. That's why you die of cancer. But you can stop the clock with telomerase, okay? It's a way of stopping the clock so the chromosomes don't fall apart and disintegrate and die. The problem is, watch out, you could also create cancer cells that are immortal and will thrive forever.
Yeah, you stop the clock for the cancer too.
Right. So that's why you have to be very careful. But anyway, what I'm saying is we're onto a new track, looking at aging at the molecular level, cancer, Parkinson's at the molecular level. And that's where quantum computers come in, because that's the home of quantum computers. We're not talking about looking at switches, which is what digital computers work on. We're talking about looking at molecules of aging.
Why is the CIA afraid of quantum
Because
mechanics?
in principle, they're so powerful you can break any digital code. This freaks out the CIA. Because how do you put a code into a computer? You put a number into a computer and ask it to factorize it. That is, multiply two numbers to create the long number. If I have a number that's 100 digits long, I ask the computer factorize it as the product of two smaller integers. That could take 10,000 years, thousands of years to solve that problem. That's why you're safe. That's why no one can break into your code, because you know how to factorize these two numbers, but the criminal does not. A quantum computer can crack it just like that, because it works at the molecular level.
Going back to the cells dividing, I understand that at any given time, like right now, all the cells that comprise my body, that they all only live so long. They're all replaced, and so there's not a single cell in my body right now that was in my body maybe a year ago.
Several years ago.
Several years ago, and there will not be a single cell remaining in my body several years from now.
Approximately. Yeah.
Yet, even though there's this turnover, all my memory stays intact. My tattoos don't go anywhere. If the cells that comprise this skin where none of them were there since I got since before I got this tattoo. How does that tattoo stay there? And how do my memories stay intact?
Well, the tattoo stays intact because the tattoos are ink.
Okay.
The ink doesn't go away. The cells can change, but the ink is still there. Okay? So you can have generations upon generations of new cells, but the ink is still there. So that's why the tattoo doesn't disappear.
Okay.
So what was the other question?
My memories.
Oh, memories are pathways. And so even though individual neurons can die, the pathway survives. Like if I have a road and I repair the road is still there, even though it's a new road, even though I repave it or change the composition of the road, the pathway is still there. So in other words, the brain ages, cells die, so on and so forth, but the brain still functions because the pathways are still there. The new cells simply replace the old cells' pathways.
And it's the same is true for brain cells, that the brain cells die and are replaced every several years?
Oh, the exact number I don't know. But yeah, cells are replaced. They don't last forever.
And in the brain. I mean, this is crazy stuff.
This is unbelievable. Michio, my guy, can we talk about aliens?
Sure.
Are they here? Have you seen any?
Yeah, take a look around. I mean,
Well,
I think he's an alien. No, he's an alien.
Are they just us from another dimension, from the future, from the past? Are they real? Are they here?
Well, first of all, you talk to any scientist, and they would say that the distance between stars is so great that it would take thousands of years to go between stars. Therefore, aliens cannot visit us. A chemical rocket takes 70,000 years to reach the nearby stars. Just one chemical rocket, 70,000 years to reach the nearest star.
But
therefore, these aliens cannot be a type 1 or type 0 civilization.
Right.
They would have to be type 2 or type 3. By that point, you begin to harness the Planck energy. The Planck energy is the energy where space and time become unstable. We cannot access the Planck energy. That's the energy more than a star has. But in principle, a type 3 civilization may harness the Planck energy, in which case they create a rip in the fabric of space-time, or they bunch up space-time and hop over the bump. So there's two ways to do it. Either you create a wormhole to create a hole in space and go through that hole, or you bunch up space like a carpet. You bunch it up, and then you simply hop over the bunched up space-time. You can calculate the energy for that. It is the energy of a star. So you would have to be probably type 3. That is galactic at the level of Star Wars, before you can even begin to think about going to the stars in an afternoon.
So if I understood what you just said correctly, you mean that if you can harness the energy of a star, then you can manipulate space-time.
In principle, yeah. If you can harness and play with the energy output of a star, then you can begin to create a hole in space and time, or bunch up space and time and hop over the hole to go be fantastic distances. And again, this concept was introduced by Einstein in 1935. He created the first wormhole paper. So he took two stars and welded them together, the space-time of two stars, and created a shortcut that would take you between the two stars. However, he also calculated that it's dangerous to go through it. You would die in the process. You'd be crunched to death if you went through the process. Since then, we have discovered hundreds of different kinds of wormhole solutions, and some of them may be stable. But again, the energy necessary to stabilize them is not for us. We're talking about a type 3 civilization.
Wow. So that's interdimensional travel. Would that be?
Yeah, that's right. You're going past the third dimension, right?
So yeah, and the reason why I brought up how big the universe is with all the stars so everything that I said, is it true that like 30% of the planets orbiting these stars are in the Goldilocks zones, which
I think
means
it's much less than 30%, but it's like maybe 5 or 10%.
So say
but that's still a lot of planets that are in the Goldilocks zone.
What's the Goldilocks?
Goldilocks is like what Earth is to the sun. Like it's the perfect distance and temperature to create life, right? But is that fair to say that? I mean, couldn't some of these be silicon life? I mean, do they have to be like? We're carbon?
Carbon has an advantage that it has 4 bonds. Now, there are other chemicals that has 4 bonds to create complex objects, but they're not as stable and they're not as rich as carbon. Carbon is rather unique. It has 4 bonds and allows you to create chains of carbon very easily, and these chains of carbon are what we are made out of, amino acids and proteins. And carbon is the best chemical out of which to create life.
So 5% of all the planets, I mean, it's possible that there is other life on planets. I mean, it's more than possible.
Oh, yeah, I think they're out there.
And so...
Whether they've visited us, I don't know, but I think they're out there.
Vinny, have you said a word?
Vinny,
I'm just trying to like wrap my head around all this and like really try to understand. I feel like I'm learning more just in this hour episode than I've ever learned in school.
Did you have any questions on string theory?
I don't even know what string theory is. I'm sorry.
I have a burning question that I was running by the guys before, and I thought that you're the only person who can answer this. I've purchased what's promised to be fogless mirrors so that I can shave in the shower. Mm-hmm. Not one of them is fogless. Is there any such thing as a mirror which I can use to shave in the shower, which will actually not fog up?
I'll have to research that.
Yeah, what's the
I'm
science
not an
behind
experimental physicist. I'm a theoretical physicist.
Right. I mean, it's just a big problem for me.
The biggest.
You know, I mean, I would be willing to pay a fair, substantial
Your fans must know.
Yeah.
Yeah, I mean, what's obviously the difference between a theoretical physicist and an experimental physicist is one actually, does it by hand, or but what is a theoretical physicist? Like, you have these ideas in your head, and you're like, well, what's the math problem on that? Like, how do you explain that?
Well, you play with equations, and when I was in high school, for example, I built an atom smasher, a particle accelerator.
As you do.
And I assembled 400 pounds of transformer steel, 22 miles of copper wire, 6 kilowatts of power, and I built a 2.3 million electron volt betatron particle accelerator in my mom's garage.
That's you on the screen right there.
Yeah, there's the coils of the machine right there. I went
why
to the
did-
National Science Fair with that
Why did you do this?
And that
because I could.
that's an example of not theoretical physicist. That's experimental physics.
That's experimental physics.
Yeah.
So I started off being an experimentalist, but then I realized that all the fun was in the equations that made this possible. So I decided to switch from tinkering with magnetic fields and spark chambers and things like that to working with pure theory and pure mathematics.
Yeah, but what do you mean when the fun is in the mathematical formula?
That's
like,
right.
When you're looking at a mathematical formula, I mean, you're probably not seeing the same thing I am. You're seeing shapes and outcomes versus just numbers and.
Yeah, that's right. Everything in an equation talks to you. Every symbol does something that you're manipulating, and it allows you to predict the future of the manipulation. So when Newton, for example, is writing equations, he could predict the future of cannonballs, the future of the motion of comets. He could predict that by moving these equations around. And that's what we physicists do. These equations are not static. They're not dead. No, they're living. They allow you to show how things move and how things change with time.
Wow.
With mathematical equations, there are theories that, based on mathematics, that the future is predetermined, right? Like
That's called determinism.
yeah. Like
Right.
and for someone to contemplate this, you imagine that when a game of billiards in a pool hall, if you understand the velocity of a ball traveling into other balls, you can calculate where every ball will end up if you understand the physics.
That's the Newtonian laws of motion, right?
Right. So by the same logic, by the same laws of Newtonian physics on a grander level, if you understand the speed of every atom in the universe, then it should follow that the outcome of every situation is predetermined.
Right. This gets us into the matrix.
Okay.
And the fundamental basis of the debate about the movie, The Matrix, is whether or not the future is deterministic, whether it's written someplace, or whether, like with the people in the movie, you can alter reality to create a new universe. Now, Newton and Einstein were both determinists. They said that the past determines the future. You know the past, you can mathematically determine how all the molecules will move in the future. Sorry about that. Whether or not you went to jail or became a Nobel Prize winner, whatever, it's all predetermined. Okay?
Yeah. And do you not agree with that?
I don't agree with that, because that was before quantum mechanics. With the coming of quantum mechanics, all hell broke loose, because now you can only determine probabilities. You cannot determine exactly what's going to happen. So when I see the movie The Matrix, I see the movie where things are determined, that you can determine how things move and how things progress with time. But in reality, you have quantum mechanics, which says that you can't do that, that there's probabilities.
Does quantum mechanics allow for every possible outcome to simultaneously exist?
Until you make a measurement, things exist in all possible states. No, Einstein hated this idea because he thought that this object exists here, it's in one physical state, I can see it, I can touch it, end of story. Quantum mechanics says no. Before you look at this object, it exists in all possible states. Up, down, sideways, burnt, melted, whatever. When you look at it, all of a sudden it springs into what you see, okay? So Einstein thought that was crazy. He would take people to his house and show them the moon. And then he would say, does the moon exist because a mouse looks at the moon? Well, according to quantum mechanics, you can argue that the moon exists because a mouse looks at the moon. Now, Einstein thought, this is nuts. This is crazy. But this is how transistors work. This is why you're listening to my voice. This is why we have electronics. All modern electronics is based on this idea. So what can I say? Einstein was wrong.
And is that sort of a reference to the slit theory again?
Yeah, that's right.
It only exists because it's observed.
Well, the observation process determines what state it's in. Because before you look at it, it exists in all possible states. Up, down, sideways, melted, exploded. And you say to yourself, well, that's crazy. Well, that's called quantum mechanics. Get used to it.
Right. Now, it's been said that time is an illusion. That time doesn't really exist. That there's only just the eternal moment of now.
Yeah, there was a funeral that Einstein went to, and he wrote the eulogy, and he made that famous statement that even though our friend has passed away, time itself is an illusion, okay? And that one little statement made at that funeral has been plastered everywhere. But it was meant to be metaphorical. I don't think he meant that time itself is an illusion, because all his work shows the time as part of his equations, not an illusion at all.
Right.
But it's been quoted often because it says, even Einstein says that time is an illusion. He meant that this person's life, okay, can be visualized. It's not dead. He's still alive. Even if it's an illusion, he's still alive in our hearts. That's what Einstein meant.
So
time is not an illusion.
So Father Time really is a thing.
Yeah.
in physics, though, isn't time? There's laws of nature and laws of physics. So wouldn't time just be the law of cycles, like seasons and kind of life's high tide, low tide,
Well,
sun
that is
rotating.
a consequence of the laws of physics, laws of Newtonian physics. The fact that the Earth rotates at an axis of a certain angle, like 23 degrees, that gives us summer, fall, winter, spring, and so that's a consequence of the motion of the Earth.
Okay. We're probably getting
Yeah,
close, but
we're-
I had one burning question. I don't know if you want to go first.
I've got a final question. So
Okay,
you go
I was
first.
just curious on your favorite space movie of all time. Or do you have like a favorite TV show, like Big Bang Theory or the movie Interstellar, or what's like the most accurate? What's your favorite?
Well, it used to be when I was a child, I would love Flash Gordon because it was a whole new world. But then becoming a physicist, I would watch a movie and I would say, no, that's not right. No, that's not right. Oh, no, they got that wrong, right? And it took the fun away.
Mm-hmm.
It was no longer fun watching science fiction movies.
Because you could not suspend enough disbelief to engage with the
Yeah, I
fiction.
knew why everything was wrong. But now I say, what the hell? Okay. This is entertainment.
Yeah.
It's a new world. It's for fun. It's for you to imagine things that might exist if we could bend a few laws of physics here and there. Okay.
But do you have a favorite?
Well, the debate is between Star Wars and Star Trek for most people.
Okay.
I think Star Wars is better for special effects and flashy things like that. But in terms of making you think of what society could be like if things were a little bit different, I think Star Trek takes that cake.
Okay.
Because it forces you to contemplate what could have happened if we had evolved in a different direction of society. It makes you think
Interesting.
after every episode.
Very cool.
Okay. Now I want to. think I want to end on this. We live in an age of mega threats. I mean, everywhere, mega threats with the environmental destruction, the depletion of resources, the economic mega threat with all the disparity of wealth, like with the nuclear threat, like just from every angle, it seems that there's something that poses an absolute threat to our existence. And I think it's very easy for people to become just overwhelmed with gloom and doom and pessimism. And in the face of all of these mega threats, do you think that there's hope for us and our way of life, our civilization?
Well, I like to look at it in a different point of view. First, I like to think that we're headed toward type 1. That is, by the end of the century, we'll be a planetary civilization. And you see the beginnings of it already. Planetary music. People listen to only a certain type of music is planetary. Planetary culture, planetary fashion, planetary songs. We're seeing the beginning of the birth of a planetary civilization.
That means like a kind of a new world order where there's only just one society.
Well, it's
one
not
culture.
like a dominating thing, but you see the beginnings of it. You see the beginnings of planetary sports like soccer and football. You see the beginning of planetary fashion, Gucci and Chanel. You're seeing the beginning of a planetary music like rock music and rap music.
Man,
So
that
you-
sounds like a very odd take on hope for the future.
So that's one trend, but that's not the only trend, okay? It coexists with this other trend toward annihilation. Because, of course, we have global warming, we have the pandemic threat, we have nuclear warfare threats, and
Debt,
eventually
just
AI
the-
threats.
Yeah,
right?
and the debt seems to be a huge threat.
Right. But I like to look at it this way. I think that the smallest unit of history is the decade. Anything smaller than a decade, you see fluctuations that are random, meaningless, and you can't make any sense of it. But when you look at life decade by decade by decade, you see a pattern. You see the fact that things are becoming more democratic, that more and more people are becoming energized and becoming a part of the future. They want to determine their own future rather than let the king or the queen determine it. But just a few decades ago, I mean, that's not the way it was. And I grew up during the Vietnam War, and I was in the United States Infantry. And the United States infantry wanted me to sacrifice my life for a cause that I didn't understand. So that was when I was your age that I had to confront life and death. And before that, my parents had to understand what was happening in World War II. Before that, we had all the wars of the 1800s, which were savage, continental wars throughout Europe in the 1800s. So when I look at the situation today, decade by decade by decade, I see the enormous progress we've made, that there are two trends in the world. One trend is being pushed by the internet. The internet has given us information, which encourages democracy. So I think that the main impact of the internet is democracy, because people are being educated. They realize they don't have to obey the king or the queen or whatever. They can create their own destiny. But on the other hand, we have weapons of mass destruction, and we also have diseases that can wipe out humanity. But I think that's always the way it's been. But maybe my point is, decade by decade, you see the progress that I would not like to have been born in the 1800s, having to be subservient to a king that was totally arbitrary with no laws or reason. We're living in an era that's democratic. And so I think that the internet has accelerated that process. So that's why I'm more optimistic, even though I realize that, yeah, it could spin the other way as well.
Okay. So AI creating protein could feed people. The controlling the weather of the planet can handle all of our resource issues, and robots can take out the trash when there's not enough in the workforce, and everything is going to be A-okay.
Well, let's cross your fingers, right? Because there's always some idiot up there who has a different vision. But I think if enough people are democratically involved in this process, I think there are going to be lots of checks and balances so we don't have these idiots up there determining our fate. And so I think that we are marching toward a much more democratic society. The internet has opened up channels of discourse that didn't exist when I was growing up. When I was growing up, it was just one person up there in the high chair making all the decisions. Now, everything's being debated on the internet, the good and the bad, which I think is a good thing. I think the march to democracy has been accelerated by technology.
Before we go, if we see a deep fake on the internet, is there a way to know if that's not real or not?
Well, I think eventually quantum computers will be at the point where you can fact check things. See, the problem with artificial intelligence today, chatbots, for example, is there's no fact checking. Because it takes from the internet, and there's a lot of garbage on the internet, puts it together and wraps it up nice and pretty. But some of it could be nonsense, because that's where it came from.
Yeah.
There are swamps. There are swamps in the internet. But I think that with the coming of quantum computers, we'll have fact-checking so that you'll have confidence that what comes out is incorrect, or it'll tell you that most likely this thing is incorrect. So I think we're not there yet. But I think the next phase of the chatbots will be fact-checking. And I think quantum computers will accelerate that process because they're going to be powerful enough to fact-check everything on the internet.
I curse myself for asking another question, but how far out are these quantum computers?
Well, right now we can create a quantum computer that is millions of times more powerful than a regular digital computer on one task. We want an all-purpose computer that can solve any problem on any task. That's still 5-10 years away.
Okay. All right.
One question. You gotta ask
come on,
one
Vinny.
question.
Vinny, come on, one.
All right.
This is the smartest mind of our generation right here.
What's your thoughts on addiction or alcoholism? Do you believe that it's a disease? Or do you think it's hereditary? Or do you think it's a choice?
I think it's all of the above.
All of the above.
It depends on the situation, depends on the purpose, depends on who's doing it and why. But I think the body, unfortunately, has a defense mechanism, the blood-brain barrier. But the blood-brain barrier is not perfect because we're byproducts of evolution. Mm-hmm. And chemicals will go right through it. And that's why there's a drug problem. And as a consequence, it means we have to have laws or chemicals or what have you to try to limit the damage created by these things. But there are gaps in our evolution. We're not perfect. And as a consequence, the blood-brain barrier will allow harmful drugs to penetrate the brain and create all sorts of havoc. And so that's one thing that we have to realize. So there are many solutions. One is the law. Two is the police. Three is, rehabilitation centers, right? But a chemical solution to the problem does not yet exist. Hopefully, quantum computers will find a way of neutralizing these chemicals so they don't damage the brain.
So quantum computing is the answer.
Quantum computing is going to save us from everything. Thank you so much, Doctor. What an honor. What a fascinating discussion.
Yeah.
Well, my pleasure.
And we got to tell everybody that you have your book. It's Quantum Supremacy.
That's right.
All right. I feel enlightened. I feel entertained, and I feel profoundly grateful. Thank you.
Okay, my pleasure.
Thank you.
Yeah.
All right. That was awesome.
Yeah, I really think that was great. There you have it, folks. I'm probably gonna sound a little bit like a douche here, but I thought I was like pretty smart on that episode. You know, like I don't know. I thought I did a good job, and whether you agree or not, you're still here at the end of the episode to hear me say that, and you know what that means? It means I love you. I appreciate you. And like I said at the very beginning, the range of guests, conversations that we had over the time in New York, I'll just tell you, we had this situation. We had this doctor, Michio Kaku, and Action Bronson, Adam Friedland, which was the biggest shit show that we've ever had. And I think it might actually be like the most wildly entertaining shit show. And then we ended it off with, should I tell him? Motherfucking G-Eazy. Yeah, it's crazy, man. It was, and we're doing a double upload week. So all of this, all 5 of these episodes are crammed into 3 weeks. And that's how we're doing it, man. We're doing it big on the Wild Ride podcast. And I don't even care if this episode got the biggest audience. It really was satisfying. And the fact that I think maybe it's for the more hardcore fans, I extra love you for being here. Have a great day. Thank you.